Top 10 Military Robots on the Planet. Welcome to a new video. Today, we're going to talk about something that for decades belonged exclusively to the world of science fiction, something we saw in movies like Terminator, RoboCop, or The Matrix, and that we thought would take generations to become reality. We are talking about military robots, machines designed to fight, surveil, kill, and survive in the most hostile environments that human beings have ever created, the battlefields. But the reality is that science fiction is no longer fiction. It is science. It is the present. At this very moment, while you are watching this video, military robots are patrolling borders, flying over war zones, defusing bombs, and in some cases, making life and death decisions without direct human intervention. The military robotics revolution is not coming, it has already arrived. And what is being developed right now in the most secretive laboratories in the world is going to change warfare forever. Throughout this video, we are going to go through the 10 most impressive, most advanced, and most influential military robots that exist in the world today. We are going to understand how they work, what makes them special, in which conflicts they have been used, and what they tell us about the future of war. Because understanding these machines is not just a matter of technological curiosity. It is about understanding the world we live in and the world our children will inherit. Some of the robots we are going to see today are relatively well known. Others are almost secret, poorly documented, and their very existence generates ethical and political debates at the international level. All of them, without exception, are testaments to human ingenuity and, at the same time, reminders of how far our capacity to create instruments of destruction can reach. So, without further delay, let us begin. Here are the 10 most impressive military robots on the planet.
Number 10. Spot, the Boston Dynamics robot dog in military version. We start this list with a robot that you have probably already seen on the internet, although almost certainly not in its most unsettling version. Boston Dynamics is an American company based in Massachusetts that has been the world reference in the development of advanced locomotion robots for more than 30 years. It was founded in 1992 as a spin-off of the Massachusetts Institute of Technology, the famous MIT, and during its early years was funded almost exclusively by military and defense agencies of the United States, especially by DARPA, the Defense Advanced Research Agency. Its most famous creation, and the one that concerns us today, is Spot, the robot dog. Spot is a quadruped robot, meaning it walks on 4 legs like a dog or any other 4-limbed animal, and is without doubt the most advanced robot of this type that exists in the world today. When Boston Dynamics published the first videos of Spot on the internet, the public reaction was immediate and divided between fascination and fear. There was something about the way it moved, the fluidity of its joints, the way it recovered its balance when someone pushed or kicked it, that was deeply unsettling. It was too animal to feel like a machine, and too mechanical to feel like a living creature. Spot weighs approximately 32 kilograms and can move at speeds of up to 5 kilometers per hour in a sustained manner, although in short bursts it can reach slightly higher speeds. It can go up and down stairs with a naturalness that astonishes, cross irregular terrain such as rocks, mud, snow, or sand, get back up on its own if it falls or is knocked down, and operate both fully autonomously following pre-programmed routes and remotely controlled by a human operator using a tablet or specialized controller. Its battery allows it to operate for approximately 90 minutes continuously before needing to recharge, although more recent versions are significantly extending that time. Its 4 legs give it a stability and terrain adaptability that no wheeled or tracked vehicle can match in complex environments. It can enter buildings through conventional doors, move through narrow corridors, open doors if equipped with an additional arm, and cross rubble or completely destroyed terrain with an ease that is, once again, almost disturbing to watch.
But what really interests us for this video is what happens when Spot leaves the laboratory and enters the military domain. The United States Navy and the Marine Corps have conducted extensive tests with Spot in simulated combat scenarios over recent years. In some of those tests, documented in photos and videos that leaked to the press, the robot was equipped with a remotely controlled sniper rifle mounted on its back. The images generated enormous public controversy and an immediate debate about the ethical limits of the militarization of robotics. Boston Dynamics quickly clarified that its use contracts expressly prohibit arming Spot with lethal systems, but the reality is that the technology exists, it is available, and no company or government can completely control how it is used once it is sold. Several countries beyond the United States are actively exploring the use of robots similar to Spot for military applications. South Korea, France, the United Kingdom, and China are all working on their own variants of quadruped robots for military use. The Chinese People's Liberation Army, in particular, has publicly displayed quadruped robots equipped with machine guns in military exercises, in a show of force that left no doubt about its intentions. Beyond the controversy over weaponization, the real value of Spot in the military domain lies in its ability to perform dangerous tasks without putting human lives at risk. It can enter a suspicious building before soldiers and transmit real-time images of what is inside, giving commanders a picture of the interior without risking any of their men. It can patrol a perimeter for hours without tiring, without getting distracted, without feeling fear. It can carry supplies, ammunition, water, and medications to advanced positions under enemy fire, covering routes too dangerous for a human. It can act as a communications relay in areas where the signal is weak. It is, in short, the first step of a military robotic revolution that has barely just begun, and that is going to radically transform the way 21st century armies operate on the battlefield.
Number 9. Talon, the bomb-diffusing robot that has proven its value in a clear, unambiguous, and measurable way in terms of human lives saved. Developed by the American company Foster Miller, later acquired by Kinetic, the Talon has been for more than 2 decades one of the most deployed military robots in active conflict zones in the world. It is not the most spectacular on our list, nor the most technologically advanced, but it is possibly the most important from a practical and immediate standpoint. Every time a Talon approaches an improvised explosive device and it detonates, a human life is saved. And those lives have names, families, stories. The Talon has saved thousands of them. The Talon is a relatively compact tracked robot that can move over difficult terrain at speeds of up to 8 kilometers per hour. Depending on the specific configuration, it weighs between 45 and 100 kilograms and can be transported and deployed by 2 soldiers without special equipment. It is remotely controlled by a human operator who can be more than a kilometer away from the robot, using a portable console that incorporates video screens, joysticks, and all the necessary controls to maneuver the robot with precision. The Talon's camera system is one of its most important strengths. It carries multiple cameras covering different angles, including night vision cameras and high-resolution zoom cameras that allow the operator to inspect objects in detail without approaching them. Its articulated arm can extend up to almost 2 meters, has multiple joints, and ends in a claw that can manipulate objects with enough precision to work with delicate components of explosive devices. It can also be equipped with additional tools, such as hydraulic cutters, drills, and explosive neutralization systems. During the Iraq War and the war in Afghanistan, improvised explosive devices, known in military jargon by their acronym IEDs, were the #1 cause of casualties among the coalition forces led by the United States.
These devices, which could be hidden under roads, inside animal carcasses, in garbage bags on the side of the road, or practically anywhere imaginable, killed and wounded tens of thousands of soldiers. Defusing them required sending an explosive specialist wearing their bomb suit weighing up to 35 kilograms to inspect the device up close. It was a job of extraordinary bravery, and despite all the training and equipment, many of those specialists died or were seriously wounded. The Talon changed that scenario radically. With the robot, the explosive specialist remains at a safe distance, controlling the machine while it inspects, manipulates, and neutralizes the device. If the robot is destroyed by an explosion, it is replaced with another robot. If the robot accidentally triggers the device, nobody dies. The cost of a Talon, which ranges around $200,000 depending on the configuration, is minimal compared to the value of a human life, not to mention the healthcare costs, pensions, and emotional consequences that come with the loss or serious injury of a soldier.
Number 8. Uran 9, the Russian robot tank that went to war. Russia has been proclaiming for years that it is at the forefront of military robotization, and while its actual advances are often less spectacular than its public statements, the Uran 9 is a concrete and tangible example of what the Russian military-industrial complex has been able to produce in the field of unmanned combat vehicles. If the Talon is a small, precise robot designed for delicate work in controlled environments, the Uran 9 is exactly the opposite, a combat beast designed for high-intensity conventional warfare. The Uran 9 has an appearance that immediately resembles a miniature tank or an infantry fighting vehicle without a crude turret. It measures approximately 5 meters in length and just over 2 meters in width, is mounted on steel tracks that give it mobility on almost any type of terrain, and its structure is made of armored steel that can withstand impacts from small and medium caliber projectiles. It weighs around 12 tons, which is much less than a conventional main battle tank, but significantly more than any robot in the category of those we have seen so far. Its armament is impressive for the size of the platform. It carries a 2A-72 automatic cannon of 30 millimeters as its main weapon, capable of firing armor-piercing and explosive ammunition at high rates of fire. Coaxially to the main cannon is mounted a Cord heavy machine gun of 12.7 millimeter caliber, equivalent to the American .50 caliber, which can be used against infantry, light vehicles, and low-altitude aerial targets. It can also be equipped with a multiple rocket launcher for area saturation and with guided anti-tank missiles such as the 9M120 Ataka, which can destroy heavily armored vehicles at distances of up to 6 kilometers. The operational idea behind the Uran 9 is to provide direct fire support to infantry units or special forces in urban combat situations or in terrain where deploying a conventional crude tank would be too dangerous or simply impossible. Think of street fighting in a war-ravaged city with snipers at every corner, vehicle bombs lurking in narrow streets, and the constant threat of improvised explosives under the pavement. In that environment, sending the Uran 9 first, letting the robot clear the way before the soldiers advance, has enormous operational appeal. The system can be remotely controlled by an operator located in a specially designed command vehicle, which is equipped with high-resolution screens, redundant communication systems, and all the interfaces necessary to operate the robot effectively. The operator can see what the robot sees through its cameras, control its movement, select targets, and order the system to open fire, although the final decision to shoot always, in theory, rests with the human. In 2018, Russia made the decision to deploy the Uran 9 in Syria to test it under real combat conditions as part of the Russian military intervention in support of Bashar al-Assad's government. And the results of that deployment were, at the same time, revealing and uncomfortable for the system's proponents.
The robot had serious and recurring communication problems with the remote operators, frequently losing control link, which left it completely inoperable for critical minutes in combat situations. Problems were also reported with the target detection and tracking systems, which failed in conditions of smoke, dust, and high temperatures typical of burning urban environments. Number 7. RQ-170 Sentinel, the stealth spy drone that was present at the most famous mission in history. When we talk about military robots, drones, meaning unmanned aerial vehicles, are without doubt the most numerous, the most varied, and the most used ones at the present time. There are reconnaissance drones, attack drones, electronic warfare drones, cargo drones, and drones designed to interfere with other drones. In the field of high-technology reconnaissance drones, the RQ-170 Sentinel occupies an absolutely special place, and not only because of its design or technical capabilities, but because of the extraordinarily dramatic story that surrounds its public existence. The RQ-170 was developed by Lockheed Martin, the world's largest defense company, for the United States Air Force, probably in the late 1990s or early 2000s, although its existence was unknown to the general public for years. Its design is that of a flying wing, meaning it has no conventional fuselage or tail, but rather the entire aircraft is essentially a large triangular wing with the engines integrated into the upper surface to reduce its infrared signature from below. This design, similar to that of the B-2 Spirit bomber, but in a much smaller version, enormously reduces the aircraft's radar signature, making it practically invisible to most conventional detection systems. The Sentinel can fly at altitudes above 15,000 meters, well above the operational ceiling of most interceptor fighters, and practically invisible and inaudible from the ground. Its high-resolution sensors, which include optical cameras, infrared sensors, and possibly signals intelligence systems, allow it to collect detailed information about facilities, troop movements, activities at military airports, and practically any activity occurring on the surface. All that information is transmitted in real time to ground operators who may be thousands of kilometers away.
Number 6. Samsung SGR A1, the sentry robot that decides who lives and who dies. We reach number 6 on our list, and this is where things become truly unsettling from a philosophical and ethical standpoint. Until now, we have talked about robots that perform surveillance, transport, or support tasks, or that attack under the direct control of a human operator. The Samsung SGR A1 is something different. It is a system that has the technical and real capability to make the decision to shoot and kill a human being completely autonomously, without any human pressing a trigger or giving a direct order to open fire. The SGR A1 was developed by Samsung Techwin, Samsung's Defense Systems division, in collaboration with South Korea's Agency for Defense Development, and entered operational service in the demilitarized zone between North and South Korea at some point between 2006 and 2007. The DMZ, known as the demilitarized zone, is a strip of land approximately 4 kilometers wide and 250 kilometers long that has separated the two Koreas since the armistice of 1953. It is one of the most heavily watched, most tense, and most dangerous borders in the world, and the perfect scenario in which to test a system like the SGR A1. Physically, the SGR A1 looks relatively harmless at first glance. It is basically a surveillance turret mounted on a fixed structure, equipped with a set of sensors that include high-resolution cameras for daytime vision, night vision, and infrared cameras for operation in total darkness, long-range motion detectors, and a voice recognition system that can detect communication attempts in Korean and identify keywords such as signals of surrender or approach. The system can detect human movement at distances of up to 4 kilometers at night and at approximately 2 kilometers during the day under normal visibility conditions. Once it detects a possible target,
The system automatically activates its high-resolution cameras to obtain a more detailed image, calculates the distance and trajectory of the target, and evaluates whether it represents a potential threat. All of this happens in fractions of a second, much faster than any human being could process the same information. The SGR-A1's armament includes a 5.5mm machine gun and a 40mm grenade launcher, enough to eliminate any human threat within its range. And here is the heart of the controversy surrounding this system. The SGR-A1 has two completely different operating modes in terms of the role the human plays in the decision to fire. In the first mode, which South Korean authorities claim is used as the standard setting, the system automatically detects and identifies threats, but requires confirmation from a human operator before opening fire. In the second mode, which South Korean authorities acknowledge exists, but claim is never activated under normal conditions, the system can fire completely autonomously, without any human confirmation. The mere existence of that second mode, of that capability to kill autonomously, has generated a deep and uncomfortable international debate. Human rights organizations, military ethics experts, artificial intelligence researchers, and arms control activists have spent years pointing to the SGR-A1 as the clearest example of a trend they consider profoundly dangerous, delegating to machines decisions that have irreversible consequences on human lives.
Number 5. MQ-9 Reaper, the most lethal hunter drone in the world. If there is one machine that has most profoundly and most durably changed the way the United States wages its wars over the past 2 decades, that machine is the MQ-9 Reaper. Its name leaves no room for ambiguity about its purpose. The Reaper is an attack drone developed by the company General Atomics for the United States Air Force, and since entering operational service in 2007, it has carried out thousands of surveillance, tracking, and attack missions in Afghanistan, Iraq, Syria, Yemen, Somalia, Libya, Pakistan, and other countries, becoming the preferred weapon of United States counterterrorism operations around the world. The Reaper is physically much larger than most people imagine. It has a wingspan of 20 meters, comparable to that of a regional passenger aircraft, and a length of almost 11 meters. It is powered by a single turboprop engine that allows it to reach speeds of up to 480 kilometers per hour, although it normally operates at much slower speeds when on a surveillance or target tracking mission. Its operational ceiling exceeds 15,000 meters, and it can remain airborne for more than 14 hours continuously with a full weapons load, and up to 27 hours on reconnaissance missions without armament. That ability to remain over a target for many hours with no crew fatigue or need to rotate is one of its most important operational advantages. The Reaper's armament is versatile and lethal. Its underwing hardpoints can carry up to 4 laser-guided Hellfire missiles, each weighing approximately 45 kilograms and with a range of several kilometers. It can also carry GPS-guided precision bombs from the GBU-12 Paveway series, smaller bombs like the GBU-38 JDAMs, and in more recent versions also AIM-92 Stinger air-to-air missiles for self-defense against slow aircraft and helicopters. The most modern variant, the MQ-9B Sky Guardian, incorporates additional electronic warfare capabilities and improved communication systems. The Hellfire missile deserves a special mention because it is the weapon most frequently associated with the Reaper and with drone warfare in general. The Hellfire was originally designed to be launched from helicopters against tanks, but over time it has evolved into an extraordinarily precise precision weapon. The most interesting variant currently in service from the standpoint of precision is the R9X, also informally known as the Flying Sword or the Ninja Blade, a version of the Hellfire that instead of an explosive warhead carries 6 blades that deploy in the final moments of flight to destroy a target with minimal collateral damage.
This variant has been used in at least a dozen confirmed operations against high-value terrorist leaders. The MQ-9 has been the protagonist of some of the most important and most controversial moments of the War on Terror. In January 2020, a Reaper launched the missiles that eliminated Iranian General Qasem Soleimani, along with several others at Baghdad International Airport, in a strike directly authorized by President Donald Trump. The diplomatic impact of that attack was enormous, bringing the world to the brink of a conflict of unpredictable proportions and provoking an Iranian response in the form of ballistic missile attacks against American military bases in Iraq. That a remotely controlled robot could generate a geopolitical crisis of that magnitude in a matter of seconds tells everything there is to say about the role these systems already play in international politics.
Number 4. Atlas, the humanoid robot that walks, runs, and does backflips. We return to Boston Dynamics, but this time with a very different creature than Spot. If Spot imitates the locomotion of a dog, Atlas imitates that of a human being. Atlas is a bipedal humanoid robot, meaning it walks on 2 legs exactly like us, and is without any doubt the most advanced robot of this type that exists in the world right now. When people talk about humanoid robots, they inevitably think of the Terminator or the androids from science fiction films. Atlas is the real version, and in certain respects, it is even more impressive than its fictional equivalents, although it is still far from having the autonomy or intelligence that cinema has led us to imagine. Atlas stands 1.80 meters tall and weighs approximately 89 kilograms, dimensions that make it surprisingly similar to an adult human being of athletic build. Its structure is a combination of titanium and aluminum parts manufactured by 3-dimensional printing, which gives it strength and rigidity while keeping weight under control. It has 28 hydraulic joints that allow it to move with a fluidity and naturalness that is astonishing. Each of those joints is controlled by an extremely complex software system that calculates in real time how to distribute weight, how to adapt movements to terrain, and how to maintain balance at all times. The videos that Boston Dynamics has published over the years showing Atlas's capabilities have become some of the most watched online in the robotics field. In the first one, a clumsy and heavy Atlas barely managed to walk on a treadmill assisted by safety cables. A few years later, Atlas was performing gymnastic somersaults on a balance beam. Then it appeared doing them on the floor without the beam, with Olympic perfection. Later, it was seen running outdoors over uneven terrain, jumping over obstacles, and finally doing parkour, leaping from platform to platform, spinning in the air, and landing with a precision that would make many human athletes envious. Each video was a quantum leap from the previous one, and the progression has been dizzying. The military implications of a humanoid robot are profound and go far beyond what a drone or a tracked vehicle can do. A humanoid robot can operate in all environments that have been built and designed with human beings in mind, without any special modifications. It can enter through standard doors, climb conventional stairs, drive military vehicles, use tools designed for human hands, handle weaponry designed for soldiers. It can move through trenches, destroyed buildings, tunnels, and any space where a human soldier can go. In theory, a sufficiently advanced humanoid robot could replace a human soldier in virtually any task, doing everything the soldier does, but without tiring, without feeling fear, without needing food, water, or sleep, and without dying in the conventional sense. The United States Department of Defense funded much of the early development of Atlas through DARPA, which in 2012 organized the famous DARPA Robotics Challenge, a competition in which teams from around the world developed robots capable of performing disaster response tasks such as driving vehicles, opening doors, cutting through walls, and walking over uneven terrain. The challenge was explicitly designed to accelerate the development of robots capable of operating in environments dangerous for humans,
with the obvious dual application of natural disasters and military operations in contaminated or fire-swept environments. The current version of Atlas still has important operational limitations. Its battery gives it approximately 1 hour of active movement autonomy, although energy systems are improving with each generation. Its artificial intelligence system, although extraordinarily sophisticated for locomotion and balance tasks, remains relatively limited when it comes to making complex decisions in uncontrolled environments or interacting fluidly with the real world beyond physical movements. But the pace of progress is accelerating, and experts in robotics and artificial intelligence agree that the distance between what Atlas can do today and what a military version could do in 10 or 15 years is much smaller than most people imagine.
Number 3. Loyal Wingman, the autonomous combat drone that flies alongside pilots. We reach the podium of our list with one of the most ambitious and most promising military aeronautical robotics projects of the current era, the Boeing MQ-28 Ghostbat, known during its development phase as the Loyal Wingman, is an autonomous combat drone designed to fly in formation alongside crewed fighter aircraft like the F-35 Lightning II or the F-22 Raptor, acting as a robotic wingman that extends the human pilot's capabilities in ways that would be impossible with only crewed aircraft. The operational concept behind the Loyal Wingman is as simple in its formulation as it is revolutionary in its implications. Imagine a pilot in their F-35 about to penetrate enemy airspace, protected by advanced air defense systems and possibly by enemy fighters. Instead of flying alone or in formation with other crewed aircraft, this pilot has alongside them one or several autonomous drones that they can control from their own cockpit with simple high-level commands of the type, "Go ahead and look for threats," or "Protect my left flank," or "Attack that target I just designated." The drones receive those high-level commands and execute them autonomously, making the minor tactical decisions necessary to fulfill the order without needing detailed instructions for every movement. The Ghostbat measures approximately 11 meters in length and has a wingspan of 7 meters, with a clean aerodynamic design and a reduced radar cross-section that gives it a degree of stealth. Its turbofan engine allows it to reach speeds close to the speed of sound, and it has an operational range of more than 3,700 kilometers, enough to accompany a crewed aircraft on very long-range missions with aerial refueling. Its modular design is one of its most interesting aspects from an operational standpoint. Different modules can be installed in the front of the fuselage depending on the mission, converting the same aircraft into a reconnaissance platform, an electronic warfare platform, or an attack platform with munitions according to what the specific mission requires. The production cost of a Ghostbat is a fraction of the cost of a fifth-generation crewed combat aircraft, which allows many more to be acquired for the same budget. It is a complete paradigm shift in the conception of air warfare. Number 2. Mutt, the ground combat robot that is revolutionizing infantry. We reach the second spot on our list with a robot that perhaps does not have the most cinematic appearance or the most intimidating name of those we have seen today, but that could have the most direct and most immediate impact on the daily life of the modern infantry soldier. The Mutt, which stands for Multi-Utility Tactical Transport, is an unmanned ground vehicle developed by General Dynamics Land Systems for the United States Army and represents one of the most concrete and closest to mass operational implementation advances in the field of military ground robotics. To understand why the Mutt is so important, one first needs to understand one of the most persistent and most debilitating problems of the modern infantry soldier: weight. The current combat soldier routinely carries between 40 and 60 kilograms of equipment. This includes their body armor, their helmet, their rifle and ammunition, their communications radio,
their night vision systems, their food and water rations for several days, their field tools, first aid materials, and all the other equipment they need to survive and fight on the modern battlefield. That load is physically devastating. It slows the soldier down, exhausts them more quickly, causes chronic injuries to their back, knees, and hips, and progressively reduces their combat capability as the mission advances. The Mutt is designed to solve exactly that problem. It is essentially an electric all-terrain vehicle with 6 or 8 wheels that can follow an infantry unit autonomously, carrying up to 450 kilograms of additional equipment. That equipment can be spare ammunition, food and water rations for several days of operations, field medical equipment, batteries to recharge the unit's electronic devices, or any other material that soldiers need, but that would be impossible to carry by hand. For the infantry soldier, the possibility of a robot carrying that additional weight is transformative in the most practical terms. A soldier who is not carrying 50 kilograms moves faster, tires much less, maintains their combat capability for longer, and arrives at the objective in better physical and mental condition. But the Mutt is much more than a simple equipment carrier. It can be configured with different mission modules that radically transform its operational role. In its fire support configuration, it can carry a mounted M240 heavy machine gun of 7.62 millimeters or an M250 caliber machine gun, remotely controlled by one of the unit's soldiers. In its anti-tank configuration, it can carry guided missiles like the Javelin or the Tau. In its electronic warfare configuration, it can carry communications jamming systems or enemy drone detection systems. And in its medical evacuation configuration, it can transport a wounded soldier out of the combat zone without needing to expose other soldiers to enemy fire during the evacuation. The system has 3 operating modes that can be changed in real time according to needs. In the teleoperated mode, a soldier controls it directly using a remote control, similar to a video game controller, being able to see through the robot's cameras what is in front of it. In the autonomous following mode, the Mutt uses its sensors to automatically identify and follow a specific soldier designated as the leader, maintaining a safe distance and following their movements without constant instructions. In the fully autonomous mode, it can navigate independently to a pre-programmed destination point, avoiding obstacles on its own thanks to its LiDAR sensors, stereo cameras, and artificial intelligence-based navigation algorithms. The United States Army is currently incorporating dozens of Mutt units into actual combat brigades as part of an expanded operational evaluation program. Number 1. The drone swarm system. The war of the future is already here. And we reach number 1 on our list. And for this spot, we have decided not to talk about a specific robot, a specific machine with a name and a model number, but about a concept, a technology, a way of waging war that is completely redefining everything we thought we knew about modern combat. Drone swarms are, without any doubt, and without there even being a close competitor, the most revolutionary and potentially most devastating military robotics technology that exists in the world today. And when we say devastating, we mean it in the most literal and most serious sense possible. But what exactly is a drone swarm? In its most basic form, a drone swarm is simply a collection of many unmanned aerial vehicles operating in a coordinated manner. But the key word here is coordinated, because the difference between simply flying many drones at the same time and operating a true intelligent swarm is as great as the difference between a group of people walking in the same direction and an army marching in formation with a common objective. A military drone swarm is a collection of tens, hundreds, or even thousands of small aerial vehicles that communicate with each other in real time, that share information about their environment, that coordinate their movements and actions collectively, and that are guided by a central artificial intelligence system capable of instantly adapting to changes in the environment and the tactical situation. Drone swarms top our list not only because they are technologically the most advanced and the most disruptive of the systems we have seen today, but because they represent the direction in which all military robotics is heading, towards smaller, cheaper, more numerous, more autonomous, and harder to defend against systems, toward a battlefield where the number of platforms matters more than the individual sophistication of each one, toward a war where the life or death decision is increasingly in the hands of algorithms and decreasingly in the hands of human beings.
And with this, we reach the end of our tour through the 10 most impressive military robots on the planet. It has been a fascinating journey, from the robot dog that patrols borders to the drone swarms that could redefine war as we know it. From the bomb-diffusing robot that saves lives to the autonomous turret that can take them without human intervention. From the humanoid doing backflips in a laboratory to the hunter drone that has eliminated terrorist leaders on the other side of the world. What these 10 systems have in common is that they all represent different aspects of the same fundamental trend, the progressive transfer of combat capability from human beings to machines. With each generation of military robots, the machines are a little more autonomous, a little more capable of making their own decisions, a little more independent of direct human control. And that trend raises questions that humanity is going to have to answer. If this video made you think, if it surprised you, if it generated a question or a reflection in you, that is exactly what we wanted. Give it a like if you enjoyed the video. Subscribe to the channel if you have not yet done so in order to not miss the next videos. And tell me in the comments which of these robots you find the most impressive, which the most frightening, or what you think about the future of robotic warfare. I read all the comments. See you in the next video.